So we're going to go ahead and do problem 3 and problem 4 at the same time. Keep in mind, of course, the following shapes. Sine starts here at a 0 and has 1, 2, 3 points of intersection. It has 1 max and 1 min. Cosine has 2 points of intersection with the x-axis. It has 1 min and 2 max. So we're being asked to make a sine graph that's got a period of 2 pi and an amplitude of 2. Well, when we graph these, there's going to be 5 points. You'll know there's if the sine 1, 2, 3, 4, 5, or if it's cosine, there's 1, 2, 3, 4, 5. So let's have the 5. Let's start off with a sine is going to start at 0. So here's the first point. And the last point in this case is going to be at 2 pi. Now, the amplitude is 2, so this is going to go as far up to 2, and it's going to go as far down to -2. You note that in the middle, it hits the x-axis again, so let's put the middle point right here. There's 3 points right now. And so the maximum is going to be here at 2, and the minimum will be here at -2. And if we go ahead and connect those, we get our lovely sine graph with a period of 2 pi and an amplitude of 2. Let's create the equation. But before we do that, let's kind of recall that period is 2 pi over b. What if I wanted to get the b by itself? If I cross multiply, I get b times period equals 2 pi. This should remind you a bit of when we had to do solving right triangles and we divide both sides by period. So we get b is 2 pi over the period. So the original is period, right? The period is 2 pi over b. But what if I want the b, the actual number to put in the equation? Because that's what we want right now. I'm going to make f of x, right? This is not inverted. It has an amplitude of 2, so you know that's 2 times sine. Okay, but now I need to worry about the b value for this x. So I need to know what this b value is going to be right here. What number goes right here? It could be a fraction. It could be a large number. We don't know. But if I use this formula to get b, well, we just said the period of this thing was 2 pi. So I could replace this with 2 pi. And those cancel out and give me 0. Just kidding. They give me 1. So a 1 goes right here. And of course, we don't have to write the equation like this if it has a 1. We could simply write it as f of x is equal to 2 times sine x. Part B, we want a cosine graph this time. Amplitude of 3. Period of pi. That means it's not going to be as wide as the other one. This is going to be a shorter, less wide, narrower graph. So cosine, of course, starts at the top at its maximum. Is an amplitude of 3. So I'm going to start here, and then it ends here. Interesting. Why does it end there? Because it's going to go to pi. So this is the entire period. And then somewhere in between, in the middle, is the lowest point, the minimum. And then in between these 2 points is going to be the intersection of the x-axis, whatever that is. And then between these two is going to be this point right here, whatever that is. We connect those points and we get this cosine value. Now, we said the period was pi, right? So let's start getting some of these things in line. If b is 2 pi over the period, that's 2 pi over pi. And hint, if we do all of this right, we're going to just get a number, right? That's going to go inside of the parentheses when we set up this equation. F of x is going to be 3 amplitude. It's not inverted, so we don't have a negative. And it's going to be cosine of 2x, right? Because this 2 is the b value. We got the b value from here. We expect a wider graph here because we're going all the way to 4 pi. It's sine. It's inverted with an amplitude of 1. So we're adding quite a few things here. We are looking at sine, so that means that we have a point right here. And it's going to end at 4 pi in this case. What's in the middle of those 2 points exactly? 2 pi. Now, we're used to, with this amplitude 1, of putting one here and one here. Oops, where is it? Here. However, it's inverted. That means it's flipped. This is a graph, remember, of that spring that's being stretched out. The period was 4 pi, so if I plug in this 4 pi right here, the pi's do cancel out, and I get 2 over 4. But that must be reduced, so your b value is 1/2. We write the function notation. This is flipped, so it's going to be a negative. This is sine, so it's sine. It has an x, and it's going to be multiplied by our b value, which was 1/2. So this is the equation for the function that models this graph right here. This is a relatively less studied aspect of mathematics, the idea of odd and even functions. They have special relationships. Odd functions in particular are symmetric about the origin, and even functions are symmetric about the y-axis. Now, what does that mean for us? Well, it means some technical algebra foolery and trickery that we can get away with. So here is our typical sine function. Here is our inverted sine function. So remember, we invert by having a negative sign in the front. Now, please compare this function right here to this one right here. Notice the sign is on the outside. The sign outside of the sign. And on this one, the negative sign is inside of the sign. That's really confusing. So notice the placement of those negatives, right? And right now we're showing you this graph. Brace yourselves. Now I'm showing you this graph. Wait a minute. There's no negative in front of this thing, so how come it's inverted? That's just the thing. Now I have both of them graphed. Let's take the blue one off, turn it back on, green one off, turn it back on. They are the same graph, which means they're the same function? Yes. Why? Because sine is an odd function. So the big takeaway here is that if I have a negative in the inside, right? If there's a negative that is a part of the b value, which affects the period, then you can go ahead and say, well, I could just pull it out and put it in front and then just make my b value inside my parentheses positive. That's the power of the odd function for sine. Here is our typical cosine graph. And again, please note the actual equation. This one doesn't even have any negatives. And here's a graph of this one. See, there's a negative in here that affects the b value. But does it affect the b value? Cosine is an even function. So the negative inside could just be thrown away because the graph's the same regardless if it's there or not. Right, here's cosine negative x. Here's cosine of x. Turn that one off. Turn it back on. Turn this one off. It's the same graph. So because cosine is an even function, the negative inside that affects the b doesn't really affect the b. So here are the big takeaways. Because cosine is an even function, any negative inside the parentheses can just be completely ignored, gone. Because sine is an odd function, any negative inside the parentheses can also be moved, however, is not disappeared. It actually goes in front and affects the inverted amplitude of the sine function. Keep them straight. Cosine disappears, sine, it reappears elsewhere.